6.5, we are solving special systems. Match the linear system with its graph, then use the graph to tell whether the linear system has one solution, no solution, or infinitely many solutions. These are the three types of special systems. You already know what one solution systems look like. These are the ones that we have solved up to this point. The new sets of solutions are no solutions systems and infinitely many solution systems. Okay, so since we are looking at graphs, whatever, we need to solve for y. So subtracting 3, y equals 4x minus 3. Dividing by 3, y equals 4x minus 3, right? Okay, so -3, up 4, forward 1. Okay, so that's one of the graphs. Okay, and another one of the graphs, let's say I do this one in purple, is -3, up 4, forward 1. Notice how that is the exact same line. Okay, those lines share every point. So every point makes both equations true. So it is infinitely many solutions. Infinitely many solutions. Okay, so solving for y, subtracting 2x. So I have y equals -2x plus 1. And subtracting 2x from this equation, we get y equals -2x plus 5. Okay, so up at 5, down to forward 1, down to forward 1, down to forward 1. Okay, so that's that line. And up at 1, down to forward 1, up to back 1, up to back 1. That's that line. Notice they have the exact same slope, which means they are parallel, which also means they will never, ever, ever, ever meet. Okay, so this is this one. And since they will never meet, they will never have a point in common. So it is no solution. Okay, and by default, this one is that one. Because I'm lazy, I'm not going to do it. Graph the linear system, then use the graph to tell whether the linear system has one solution, no solution, or infinitely many solutions. Okay, solving for... In order to make things go faster, I have solved for y in all of our equations so that we can graph quicker. If you need to solve for y, pause the video, solve, and then continue along. Okay, so to solve this one, we start at -1, and we go up 3, forward 1, up 3, forward 1, down 3, back 1. Okay, there's that line. So graphing the other line, we start at 2, up 3, forward 1, down 3, back 1, down 3, back 1. Okay, notice that these two graphs have the same slope. Their slope are both 3, which means they will never ever meet. So there will never be a point where they intersect, so it is no solution. Okay. Moving on, -2, up 1, forward 2, up 1, forward 2, up 1, forward 2, down 1, back 2. There's that line. And we start at 3, down 2, forward 1, down 2, forward 1, down 2, forward 1, down 2, forward 1. There's our graph. And they cross at 2, -1. So that is one solution, and our solution is 2, -1. Okay. Again, I solve for y first, so doing the purple equation, we start at -2, and then we go up 4, forward 1, up 4, forward 1, down 4, back 1. Okay. Hopefully it crosses or doesn't cross on the paper. Okay. Starting at 3, we go up 1, forward 3, down 1, back 3. Okay, there's a point there. help us. Okay, well, we have a point where they cross. Oh, all we have to do is tell them whether it's one solution, no solution, or infinitely many, and it is one solution. We don't know the exact point, but it is right there. Okay, so graphing the pink, we start at 6 and go down 3, forward 1, down 3, forward 1. Purple, start at 4, go down 3, forward 1, down 3, forward 1, up 3, back 1. Again, they have the same slope, so they will never, ever, 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 ever meet. No solution. One of these has to be, maybe not. Boring. Okay. And starting at -4, up 2, forward 1, up 2, forward 1, up 2. Oops, I forgot to go forward 1. How many of you are yelling at me? Most of you. Haha. Okay, and -1, up 2, forward 1, up 2, forward 1, down 2, back 1, down 2, back 1. Again, they have the same slope. They will never, ever, 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 ever meet. No solution. Okay, we need to solve the system using substitution or elimination. Okay, this one is set up for elimination because the 2's are the same, it's in columns, and they're opposite signs. Opposite signs we add. 3x plus x is, oh, by the way, typo, add 8. 3x plus x is 4x. Negative 2y plus 2y is 0y. Don't need it. 8 plus 8 is 16. Divide by 4, divide by 4. X equals 4. Plugging it back in. I'm going to plug it in the bottom one. 4 plus 2y equals 8 minus 4, minus 4. 2y equals 4. Divide by 2, divide by 2. Y equals 2. So 4, 2. Clearly one solution. Okay, this one is again set up for elimination because they're already in columns, but we have to multiply first. So we're going to multiply through this top equation by 2. So I'm going to rewrite it below it so that I don't have to rewrite that second equation. 6x plus 4y equals 8. Okay, adding together because they're opposite signs. 6x minus 6x is 0x. Negative 4y plus 4y is 0y, which is 0. Negative 8 plus 8 is 0. Okay, 0 equals 0. That is true, so it is infinitely many solutions. Okay, this one is again set up for elimination, so I'm going to multiply through by 3. Okay, writing it below. 3x plus 3y equals 150. And add them together. Negative 3x plus 3x is 0x. 2y plus 3y is 5y equals 150. Divide by 5, divide by 5, y equals 30. Plugging it back in. Okay, x plus 30 equals 50 minus 30 minus 30, x equals, 20. And the last one, we are going to multiply by 2. Sorry, I'm favoring elimination instead of substitution, mostly because substitution is a pain in the butt. Negative 6x plus 4y equals 2. Negative x minus negative 6x minus negative is plus, so 6x minus x is 5x. 4y minus 4y is nothing. Negative 3 minus 2 is negative 5. Divide by 5, divide by 5. X equals -1. Plugging that back in, -1 plus 4y equals -3. 1 plus 4y equals -3 minus 1 minus 1. 4y equals -4. Divide by 4. Divide by 4. Y equals -1. Haha, off the page. -1, -1. That's a boring answer. Okay. Questions with that? I should do the next problem, but I'm not going to. Have a good day.